All right, I guess we can get started. So thank you all so much for coming to my talk on TLS, basically outages and oopsies, how you can knock yourselves offline with some simple misconfiguration options. So for those of you who don't know, I'm Mark, and I work at Plaid. Basically, I do cloud infrastructure engineering. Basically, I do what you need to do to keep Plaid running, but that no one really wants to do. That falls on me. So I work on really weird projects. So before we get started, I really want to bring up this disclaimer. All these examples are real. They happen to real people. I've gathered them from a wide variety of places, and I've anonymized them as much as I can, unless they're massively public. Basically, no one likes to admit that they had downtime because of security. And before anyone gets too confident that I would never make that mistake, I guarantee you were doing at least one of these and maybe all of them. So when people talk about security, everyone reaches for TLS. It's got great PR, everyone knows the name, there's lots of documentation, recommendations to say hey, go do it. But the quality of documentation around it is abysmal. It's often written as a way to try to sell you a vendor solution that's also not terribly good. And it's built up a lot of old wives' tales of oh, do it this way, do it that way, set up this thing, set that thing up, without really thinking about why you do it. So it's got this large legacy of ideas that are just sticking around. So by the end of this talk, you will be a shining beacon of TLS knowledge at your company. I'd like to say that it's all my fault for making such an excellent talk, but the reality is the standard of knowledge of TLS is very low. So everyone wants security. Companies say they want security, but they really only care when things are on fire. So this is never going to be a priority for a lot of companies. The good news is that doing this correctly is actually pretty easy. You can even start doing this today. But I really want to emphasize your customers pay for uptime. That's what they care about. They will pay lip service to security, but if you're down, that is a major problem for them. So when you think about these solutions, you want to start from the operational side of how do we make this automated? How do we keep this working all the time? Marginal improvements in security don't matter if you're offline. So you want to think scalable and maintainable beats theoretically perfect. And honestly, the hardest part you're going to have is throwing away your current rule book or the current way you're doing something, because people love the status quo. So I keep talking about TLS, but again, who really knows what it does? So here are the four key parts of TLS. We have certificates, there's encryption, authentication, and authorization, and those last two are different, despite the terrible, terrible naming. So encryption is the simplest part of TLS, and it basically just always works. So it is the actual part that makes it so people can't read your communication between servers. It handles the key exchange and the cipher negotiations, and those two are pretty important, but also pretty simple. At its core, the client just says, hey, I want to talk to you. Here are the cipher suites I support. Here's my key. The server picks a cipher suite, hands back its own key. Boom, encryption done. This part of TLS basically never fails, which is great, but TLS is so much more than just protecting end-to-end communication. The next thing that it has is authorization, and this is what you're allowed to do inside your system, and that's just not in TLS. It's not in the spec at all. If you want that, you have to build it yourself. So often people will use OAuth. Amazon has this really interesting product called IAM Roles Anywhere that uses TLS, but it is built on top of TLS. It's not a core component. So you can feed TLS into your authorization system, but it's not in the box. It's not a standard feature, and you'll have to manage it yourself. Now, authentication, which is slightly different, is basically it's who you are. So at its core, you have a subject, which is usually a domain name. So you've got your google.com or whatever. But it doesn't have to be. You can literally put anything in there. It's just a free-form text field. So you could have usernames. You could have email addresses. You could ask for a certificate for a domain name you don't own. You can kind of go wild. And the other part of the authentication is the certificate above you that signed it, that says this is accurate, because that's effectively one of the core concepts of TLS. It's this chain of trust going from the bottom to the top. So I keep talking about like certs and signing. So at the very bottom, we have a leaf cert, and so that would be for like Wikipedia. You connect to Wikipedia, you download this, it says, I'm valid for Wikipedia. There's an intermediate cert above it that you don't have to have that, but it's very common because it makes managing the whole TLS chain much easier. And so you as a client don't trust these two certs that you download from Wikipedia. After all, how do you know that they're actually correct? How do you know that you can trust them? And the way it works is you have a root cert living on your machine already that you explicitly trust just for everything. So the big ones, you've got ISRG, which is Let's Encrypt, but Google, Amazon, Microsoft, they all run their own root CAs. There are other private ones like DigiCert. So effectively, as long as you trust the very root, anything that's signed iteratively will be trusted by you too. So when you think authentication, it's who you are, but who you are isn't that hard to decide. You can get a certificate for a phishing domain name really easily. You know, Plaid with 3 Ds is always available. You go buy it, you get a cert for it in 10 minutes. So it's not this hard-coded ID. And you also want to think about who's attesting your identification. I mean, can we trust DigiCert? Probably, but the Beijing Certificate Authority, which is in China, is also a trusted root cert. And while they haven't misbehaved yet, there's always a first time. So I've talked about these root CAs, and like, really, like, what are they? Basically, it's a group of companies that Mozilla, like Firefox Mozilla, trusts. They have said, we can trust these people, they're reliable, they will follow our rules. The standards to be a root CA are actually pretty tightly enforced these days. You know, you have to get audited, you have to have control policies, but there's a lot of foreign governments on this list too, and they've promised to follow the rules, and they have so far, but nothing's stopping them from going wild in the future. And you know, Symantec, if we all remember them, they used to be a root CA until they broke the rules. They got kicked out, and their root CA business is dead. Entrust, if you're familiar with them, they're a current root CA who is in the process of being kicked out because they wouldn't follow the rules, they wouldn't revoke bad certs, they just did not comply. And so Entrust is basically going to be dead by the end of October because they are just, once you're kicked out, you don't have a business. So I keep bringing up a certificate, and this is the basic currency of TLS. So, but like, what actually is it? At its very core, you have the public key and cryptographic details about it. The private key is held elsewhere. It doesn't have anything to do with that. It's just a little private key you keep somewhere else. But you have your public key in your certificate. You also have a start and end time. And so that means your certs, they're no good before the start date, and they're no good after. They have a fixed life. And there's no way to get a cert with an infinite life because they all expire. You've also got the owner details, so like who you are. And at the very bottom, it's just like, hey, I just own this domain name. You can buy certs that say, oh yeah, this is a real company, we've verified this. The problem with that is no one checks those. So where's the value that you're getting? It's also going to have a list of valid domain names that your cert is good for. So you could have like the old star.google.com, which is good for almost anything, or you could have a list of tens, hundreds, or dozens of certs that, or sites that the cert is valid for. And then finally, you got the certifier, the group that's one step up who's saying like, yes, this is right, yes, we can trust them. So what happens when this all goes wrong? So a little while ago, Spotify had an outage where their public TLS cert just expired. They were down for an hour. None of their customers could get in. Everyone was just locked out. And what happened was their certificate expired and no one caught it in time and no one renewed it in time. Someone forgot that like certs have a fixed and finite lifetime. They probably had a manual process to update this. And there was no alerting and no monitoring. So if you don't monitor these, it's really easy to miss an update, especially if you're buying them from DigiCert or Entrust or anyone like that. They love emailing you. They don't like automation. And a manual cert renewal can take hours. Like we've had challenges with DigiCert taking just hours and hours and hours to renew certs. So this isn't a quick fix, so you could be down for the better part of a day if you're particularly unlucky. So what if you do want to keep up and running? Well, you have to lean into automation. CertBot and Let's Encrypt are really great for this because they will refresh certificates automatically for you. You don't have to think about it. It literally just works. If the CA you have doesn't support first-class management as a first-class citizen, you should get a new CA. And sadly, the only one that I really think does this well is Let's Encrypt. Everyone else wants to move you to a very manual process. Basically, they get more money that way. You also have to monitor your certs. You need alerts for when your certificate is about to expire, so that if your automation doesn't fix it, you can go in and fix what's going wrong. Like Nginx will export as a metric when your certs are going to expire, and you can set up alerts that will page people if they only have a day or a week of lifetime left, so you have time to fix these things. And finally, as of now, TLS certs will expire every year at least. You can't get a cert that's valid for more than 13 months. Some CAs will only issue 90-day certs, because, particularly Let's Encrypt, because they're very much on the, you should be automating this, not manually maintaining things. So what happens if it's not the cert that's breaking, but the platform itself? So inside TLS, there's, your TLS implementation will have like a list of cipher engines that it's allowed to use. And during the negotiations, you pick one that both the client and the server accept. But cipher engines get pulled out of service over time. They'll have bugs in them. They'll find cryptographic flaws. The key lengths won't be long enough. So over time, they just throw them out. So what had happened here was a server upgraded, dropped support for the cipher that the client supported. They couldn't talk to each other anymore. They were hard down. And the result was hours of downtime while this was figured out, and required an emergency Java upgrade. So if you think regular upgrades are fun, imagine being down and having to do a panic major library upgrade. Basically, it happened because they were running end-of-life code. No one was doing upgrades, no one was watching this. On the server side, they weren't doing any customer monitoring. And it's a good idea. Like, you can monitor what your customers are running, and if you find that they're really out of date, send them an email. Just say like, hey, we've noticed this, you should fix it. Especially if you're doing a major upgrade. Customers love customer support. If you can help them out and say like, hey, we've noticed this, you should fix it, always makes you look good. And finally, just realize like TLS is a moving ecosystem. You can't stay static. They keep finding problems, you have to keep moving forward. So if you want to prevent this, you just can't run EOL software. Tell your customers, don't run EOL software. Tell your suppliers, don't run EOL software. If you have to, and there's always a case for why you have to, buy the extended security support. It's very expensive because the vendor knows you don't have a choice, but they will keep patching your system. They will keep giving you updates. They will keep making sure you are ready to go. Check your logs. If you're doing these upgrades, TLS has a way of saying, hey, my customers support these ciphers, and you could go find out who will be affected in your next upgrade, who's at the edge of falling off. Reach out to them. All the platforms that exist, so Java, Node, Python, Linux, all the security features and security libraries, they're integrated, but they're not like a core part. So you can upgrade them separately. You can upgrade Java crypto libraries, Node crypto libraries, all of that without updating the core platform. It's not perfect, but it does let you keep ahead of what's going on. But at the end of the day, you can't run EOL software. You do have to have a plan for upgrading them, even if it's not immediately. You should like slowly work on making sure that you're with the stream. So here's another fun TLS outage. So one day, traffic between company A and company B just died. None of the other people that A and B talked to were affected. It's just this connection. Now this one took hours to diagnose because the traffic volumes were so low it was below the alerting threshold. But eventually they figured it out. So a support ticket had to bounce around between the two companies until an engineer actually dug in. And what had happened was A, rotated a certificate because they expire, and B, pinned them. So pinning is where you take a cert and say, I will only allow this cert to talk. It sounds great from a security perspective, but from a maintenance perspective, they expire every single year, and you can't get around that. People also keep saying, hey, we should pin certs, we should pin certs, we should pin certs. There's a lot of stuff on the internet about pinning certs is a good idea. So how do you deal with this? What do you prevent? Well, one option is you could email your customers all the time telling them that you're updating your certs and hope that they fix that. No, don't do that. Don't email your customers. That's not going to work. Tell them don't pin certificates. Ask them do not do this. If you have manual steps, it's death for reliability. They get missed, they get forgotten. Someone goes on vacation, things break. OWASP used to recommend certificate pinning, but OWASP is just a GitHub repo. I opened a bug and said, hey, we should fix this, and they did. So now their recommendation has changed to say don't do it. So if you find someone citing OWASP, you can always go change it. They're very receptive to new ideas. Publicly state in your documentation, this isn't supported, don't do it. You can even rotate your certificates frequently. You could report them or rotate them every month. So if someone pins them, you find out really quick. Write into your contracts not to do it. Tell your customers, tell your suppliers, you won't count them being down because of certificate pinning against your SLA. So what happens if you get too clever by half? So again, different A, different B, but all the traffic died again. So someone realized that the end certs, the leaf certs expire every year, but the intermediate and the root certs, those last 3, 5, 10 years, those are safe to pin against, right? Because they last forever. That's less than accurate. So when you renew a cert, your provider can choose to give you a different intermediate cert. They do it because the old one, maybe it's less secure, maybe they want to give it a new name, maybe they're migrating to a different root cert altogether. All you know is that it's changed. Some of them will let you pick the intermediate cert, some of them won't. But every time you renew a cert, you could get a new intermediate, you could get a new root, and you might not have any choice in when that happens. Anytime you get a new cert, everything could change. So, leaning back in, please don't pin your certs. Don't pin the intermediates, don't pin the roots. They're subject to change every year like everything else. If this is really important, monitor the cert revocation lists. They're updated frequently, so you can monitor when things, when your CA say this cert has gone bad. Luckily, cert revocation list monitoring is built into all the core libraries, so you don't even have to do anything. It's just on by default. So what about mTLS, everyone's favorite buzzword? So this is mutual certificate validation. So you're validating the client and the server. The good news is you have twice as many points of failure, so you have twice as many opportunities for downtime. So we have the regular server validation. It's still fine. But the server is now validating the client. So the client will send a certificate to the server and what is it doing? So it's got this cert, it tries to validate it, but what is it validating really? The core reason you'd want to use this is you have a trusted third party that can verify both sides of this. But in a lot of cases for the client, you're just some IP address with a certificate in hand. What does that actually mean in this context? So it was signed by someone, but you've got a subject name, but there's no way to map the subject name to where you're called from, so you can't trust that as a way to check. There's no domain name. Are you even validating anything? Like, what are you trying to ensure that this person has? Like, if it's just that they have a cert, well, okay, you've proved that they own a copy of OpenSSL, which, I mean, it's awful to use, but it is a thing. Some systems have fixed lists of certs that they check against. So now you basically have an auth token that expires, is hard to decode, and is annoying to work with. You could be checking SAN in the public root. So you could say this is signed by a public root CA, and it's a SAN. But then how do you map this thing to an actual client? Are you just saying like, okay, you've got the cert, you're in? Well, why even have it? Are you maintaining an internal list of this SAN maps to this client? Hope they don't change it. Finally, you could set up your own private root CA, but most of that just proves that you're a huge TLS nerd. It's a lot of work. It is good for security, but no one really wants to do that. So mTLS is most often used in things like service meshes. So this is like internal systems like Kubernetes, server-to-server communication. And it's used in service meshes because you don't want your entire system to collapse because the validator pod died. You want to hand out an authentication token that lasts for hours, days, maybe a week, rather than, hey, is this API request okay? Is this API request okay? So what had happened was the engineer rotated the root certs for the service mesh. Thought, hey, that's not hard. Everything has to have a root cert. It worked fine for several hours. They rolled it out to production. It's all good. Widespread outage because the certs lasted for 2 days, and that's about when they started expiring. So just the network was dying. Basically had to restart all of production to get new certs, to get new root CAs pushed out. The engineer thought the update was instant and didn't realize the certs had to migrate out, that they had to be updated over time. So how do you prevent this sort of situation? Any situation where you have a root cert, which is all of TLS, you have to rotate them. The root certs expire, they get compromised, they just have to get swapped out. They last longer than anything else, but that just means you're updating them once every 5 years instead of once every year. If you control all the endpoints, you can push out a new update in days or weeks, not too long. If you don't control the endpoints, it's years. DigiCert, all them, when they want a new root cert, they have to get it into the root cert bundle. They have to wait till it's installed in Node and Chrome and Firefox and Java. They know that takes years. They know uptake takes forever. So they start early and think, okay, in 3 years we can start using this. Imagine if you had a 3-year lead time for an update. You have to plan to rotate them if you're going to be using them, but just be aware, rotation is hard and not well documented. So what if you want to do mTLS between organizations? A and B, we want to use mTLS to talk to each other. Fundamentally, cross-organization mTLS is broken. There is no standard for key exchange or for the root key exchange. Everyone does their own thing. Everyone does whatever. It is an absolute mess out there. So when you go back to your organization and someone says, I want mTLS, really think about, does this give you any benefit? You don't get authorization. You have to build that yourself. Authentication might be really weak. You might not have a way to map a TLS certificate to an actual named customer. And at that point, it's a really fancy password. It's also incredibly hard to debug. Everything is non-standard. Customers, upstream and downstream, they're going to have weird error messages that are specific to their stack that if you're not familiar with Java, what does NSS failed mean? So let's talk about doing mTLS really wrong. So one day security says we just have to have it, turn it on. Someone emailed you a certificate. And I mean, you can trust email. No one's ever been hacked that way, right? Some poor engineer took it, shoved it into an Nginx pod, wiped their hands of it, we're done. So no one did a threat assessment and figured out, like, why would you care about this? It should be fine. No one actually thought about the KTLO requirements. So you've got all these certs that you're now having to update, which will fail. No one's thought about monitoring them, I guarantee you. And no one actually thought, like, okay, what's the user modeling? What attack are we trying to prevent? Just, we need it, do it, hope for the best. So the first problem is if you send your certs over email, you're asking to get hacked. I guarantee you there's going to be a really famous attack where someone sends a cert over email, they get popped. No one monitors for the expiry of these things. They're just in there, hope for the best. Maybe they'll send you a cert that only lasts 7 days because they weren't thinking about it. Maybe they made a mistake. What if they sent you the Let's Encrypt root cert? Because of TLS and how it works transitively, that means that root cert will, anyone with something signed by the Let's Encrypt root cert is in. Are you checking the certs? Are they valid? If you look at a cert in plain text, it's just base 64 encoded nonsense. You can decode it, but who's got the time? Even if you know how to decode it, why would you? Surely you can trust, a PM at a different company not to have made a mistake. And it's manual steps upon manual steps. Every manual step is an opportunity for an outage. That's just the core concept here. Automate, automate, automate. So if you need mTLS, come up with a threat assessment. Like, think about, what am I trying to prevent? Start with that. And if you have an attack that will be prevented by this, that's a reason to use it. But if you just say, hey, someone wrote it down that we have to use this, go back to them and say, like, what are we preventing? What are we trying to do here? Why is this better than an auth token or a JWT or just a good password policy? Think about how this has to tie into your authentication and authorization story. By default, Nginx treats it as a dumb permission token. It's basically, a standard HTTP basic password at this point. And if you're not getting any of the advantages out of this, if you can't tie this into a specific named user with specific authorizations, what benefit are you getting? Finally, what is your maintenance plan for these things? They all expire, you have to keep them up to date, you have to deal with customers who have to rotate them. It is maintenance heavy, it is a KTLO time bomb. Really think this through and say, do we get benefit out of this? There are people out in the lobby who sell authorization solutions and authentication solutions. Talk to them and maybe buy one of their products rather than going down this route. Finally, you're going to get lots of questions of, hey, can we just do this? Come on, just do it quick. It'll take 5 minutes. It'll take 5 minutes now, and then 5 hours of downtime on Thanksgiving. So if you really want to do mTLS right, and this is kind of hard, you only want to provide the root certs. You want to give them long lives of 5 or 10 years. Now you want to add what's called a name constraint to the root cert. So you say this cert is only valid for signing things in plaid.com. So you can take that cert and trust it. But if I'm malicious and sign google.com with my Plaid cert, your tooling will know, hey, this thing's squiffy, there's a problem. Your mTLS certs shouldn't be signed by public CAs. That's not what they're there for. They'll happily take your money, but you're wasting your time. Think of a low-touch way to distribute your root cert. If email isn't low-touch, it's going to get lost, it's going to get forgotten. Amazon themselves struggles with begging people to update their root bundles. I've had 2 or 3 near outages from Amazon where, hey, we have to restart these databases because you need a new root cert bundle because they're expiring in a month. And like I said, when they expire, they're dead. For mTLS, consider putting it behind a security evaluation where you just talk to the customer and see like, hey, have you thought through these maintenance requirements? Is this something you genuinely need, or was it just something you were told to do? So just like engage them proactively and try to make sure that they're actually getting the benefit out of this, rather than just like following along and doing checklist security. So when you want to like give out your root certs, they're not secrets. No paywalls, no logins. Give people a nice URL and say, here's our root cert bundle. Anyone can access it. You want someone to be able to like download this on your machine startup. When you're building Docker images, download this bundle. S3 and CloudFront are a great way to do this. You could even put your root certs into DNS. There are record types that are intended for storing certificates. Give your customers scripts that will do this. Tell them run these every 90 days, put them in cron tab, download them on machine startup. You want customers updating these things, you know, every 90 days, regularly enough. You don't want to be in a situation where they got emailed once and now they're forgotten. They're lost in some GitHub repo. They're baked into a Docker image that's dead. You want customers updating these things as regularly as they can. So I guess one of the core takeaways is, keep your software up to date, please. It'll solve so many of your problems. When you're doing TLS, don't get clever. The platform defaults on any platform that's worth running are the correct ones. They have the right security, the right validation. They check everything correctly. Lean into that. You probably don't need mTLS. I'm not going to say no one does, but you should consider, does this solve an actual problem that I have, and is it the best way to solve a problem that I have? Finally, if you have any manual steps in TLS, you will have an outage. It's just a matter of when. And the only way you will avoid outages is really obsessive infrastructure people. But even then, we go on vacation, alerts get missed, you will have an outage if there's manual steps. So I want to thank everyone so much. Thank you all for coming. We do have some extra time for questions. Yeah, if you have any questions. Yes?
Thank you very much. Two quick questions. The first one's a little tongue-in-cheek. What do you do when one of your enterprise clients won't sign their contract until you enable mTLS and there happens to be a large global card network? That's just, that's what we like at the moment. It's pretty interesting. We've been trying to fight this thing and they're like, no mTLS, no deal, which is really frustrating. Especially what you've just spoken.
Yeah. Like at some point, so the question is like, how do you deal with customers who have to have mTLS, maybe not for great reasons, but hopefully for good reasons? If you can, like you really want to speak to their security people and like sit down and talk with someone who really knows what's going on. Figure out like what their concerns are, because what's probably happened was someone said, oh, we should do this, and then it got baked in, and now there are PMs and salespeople arguing with each other.
It's
and
just a checkbox.
Yeah.
No deal's done without. But I'm not asking yourself that. The
Yeah.
actual question was more around with PKI, obviously you've got quantum computing coming.
Yeah.
There's going to be some massive changes when you can factor two file numbers in a few seconds.
Mm-hmm.
Everything breaks. You or Plaid, you put any thought to what's happening with PKI?
So the question is, what can you do to like protect yourself against quantum computing and then the attacks against public key infrastructure? The reality is you just have to like keep checking on what like the state of the research is. There are some algorithms which are quantum computing resistant, but also sometimes you just have to keep abreast, because like there's going to be some point where, oh, I have to re-encrypt everything because this old key just isn't secure. And the attack might not be quantum encryption. It might be someone stole my key. It might be, hey, the key is 10 years old and it's just too short and we can break it now. So you just need to be in a situation where like at some point you will re-encrypt your data. And it's going to be a huge pain, but that is going to come. All right. Any other questions? right, cool. Thank you so much for coming.